So exercise related to simple harmonic motion. An object undergoes a simple harmonic motion. Acceleration and displacement are directly proportional, and it's always directed towards the mean position. And angular velocity for the simple pendulum and for spring system is different. You have to memorize that formula. We'll start with question 9 first. Question 9, as you can see, a Bluetooth speaker enable music to be played from a phone or other mobile devices without the need of a wire connection. The speaker rests on three rubber feet as shown. As you can see, the rubber feet are there. The rubber feet maintain contact between the speaker and the surface uh, when it's on and it is on. Why the sound is loud when the speaker is on hard wooden surface? So what might be the reason why the sound is much higher when it is placed on the large wooden surface rather than on a like a rubber? So as a result, what will happen? Because in this case, what will happen? The sound which is produced by the speakers cause a vibration to the because the wood will not. So as a result, like what will happen? The speaker is there, and these are the supports, and it is producing a sound. When it is producing a sound, why the sound appeared to be much louder? So what actually happened when the speaker is vibrating? This causes a vibration to the wood as well by applying a frequency equal to natural frequency of the wood. So here the driving frequency of the sound, because the sound produced by the or a vibration of a speaker cause a vibration of the wood, and when it causes a vibration of the wood will vibrate with a maximum amplitude, and then it disturb the greater amount of air nearby. So as it disturb the maximum or a greater amount of air nearby, this causes the sound to be louder. So what will happen? The driving frequency of the speaker matches with the frequency of the wood, or you can also say the speaker force the wood to vibrate, and as a result, because wood is having a large area in contact with the air, this causes a maximum sound to be produced. Is it clear, this one? As compared to a, if there was a rubber, like rubber will absorb maximum amount of energy, so as a result the sound will decrease. For certain frequencies of the sound, there is much large increase in the loudness of a sound produced. Why this increase of a sound occur for a certain frequency? So here you have to explain the concept of the resonance. Like every material is having its natural frequency. So when the frequency or the driving frequency matches with the natural frequency of the wood, as a result, it will vibrate with the maximum amplitude, and it will absorb maximum amount of energy. So the points you will mention, the resonance happen when the driving frequency is equal to the natural frequency. And natural frequency means amplitude of the vibration will be maximum, and greater amount of energy is transferred or maximum energy transfer. So, so what actually happened, like if this is a wooden board and there's a speaker on the wooden board, which is producing a sound, say it produces a sound of 70 hertz. So this will cause a vibration. This will vibrate, but this 70 hertz may not be equal to the natural. If the natural frequency of a wood, example, 120 hertz, so when the sound of a frequency 120 hertz is produced, that sound will be much louder as compared to a sound of a frequency 70 hertz. Because when the sound is having a frequency of 120 hertz, it matches with the natural frequency of the wood. This causes a maximum energy to transfer to the wood. And when the wood will vibrate, it's caused the nearby air to vibrate with the same frequency. So the sound appeared to be much louder than what it was actually produced. Question 10. When a ship is sailing on a rough sea, the wave can set up a ship into a simple harmonic motion. So example, a ship is there and the sea is rough. So it causes a vibration to the ship. It can cause a simple harmonic motion. This can result in passenger become seasick. What is meant by the simple harmonic motion? 2 mark. So how you define the term simple harmonic motion? The 2 points. The first point, that acceleration is directly proportional to displacement from the mean position. And the force or so 1 point is acceleration is directly proportional to displacement from the mean position, and it is acceleration is always directed towards the mean position. So these are the 2 points you will always refer, that acceleration is always directed towards the mean position. And the second point, acceleration is proportional to the mean position. Sorry, acceleration is proportional to displacement from mean position. So these are the 2 points, or in place of acceleration, you can also use the term force. You can say force is directed towards the mean position, or force is proportional to the distance from the displacement from the mean position. At one position, this sorry, the passenger experience a vertical amplitude of 0.85. Calculate the maximum acceleration. So how we can work out the acceleration? Acceleration is omega square a, or x you can say. If the maximum velocity is there, maximum velocity is omega into amplitude, and maximum acceleration is omega square a. Maximum acceleration is omega square a, and maximum velocity is omega a. So we need the maximum acceleration. So we need a is equals to omega square and capital A. A is the amplitude, which we have. But we need omega. How to work out the omega? As they did not, they mentioned the time period, with a time period is mentioned. So what is the relation between omega and time period? Omega is 2 pi divided by t. So it will be 2 into 3.14 and divided by the time period, which is 6. So this will be 1.05 radian per second. Now we need A. So it will be 1.05 square. And the negative sign shows it is like directed towards, that's the significance of a negative sign, that it is directed towards the mean position. The amplitude in the question is given 0.85. So when you multiply, you will get negative 0.937 and meter per second square. So this is how we work out the maximum acceleration. If it was a maximum speed, then V is equals to omega A. Omega A is already given, and omega the same way you will work out 2 pi divided by T. Passengers on a ship may suffer. Yeah, it is necessary to put a negative sign to show that acceleration is directed towards the mean position. That's right. The passenger on a ship may suffer a seasickness as a ship rises and fall on the wave. The graph shows the limit of the passenger tolerance of oscillating motion. Acceleration due to gravity, uncomfortable, tolerable, and not noticeable. Period of the motion is there and the acceleration. Determine whether the passengers are likely to feel the seasick as a result of the ship motion. You should use your value from B1. So our value for B1 was acceleration, the maximum acceleration, which was negative 0.93. 0.93 was there. Now, and the acceleration due to gravity, as you can see here, acceleration due to gravity is 0.2, 0.1. Different values are given because like this is representing the value for a G, which they and this is a period of the motion. So period of the motion was 6. Now how you can work out the acceleration due to gravity, the value of a G from the given value, because and then or using a time period, like this is a time period for not noticeable, the value should be about like 0.05, and this is acceleration divided by acceleration due to gravity, means the ratio between them. So what about the acceleration? The acceleration is minus 0.93 divided by the acceleration due to gravity, which is 9.8, because this is a value acceleration divided by acceleration due to gravity. Our acceleration was 0.93 and divided by the acceleration due to gravity, which is 9.81. So when you divide these two numbers, what we'll get 0.93 divided, so 0.095. So 0.095, okay, 0.0948 or 95, I just rounded out. So 0.095 will be somewhat here. This will be somewhat here. So means the ratio and the time period was 6. So it will be like tolerable, because when the time is 6, and the acceleration ratio between acceleration and the acceleration due to gravity was 0.095. This is a point of intersection. So this point of intersection is what? This point of intersection is like within the tolerable range. So the passengers, that the graph, as you can see, it is within the tolerable. So they have a low chance of getting a seasickness. Is it clear? Then the graph shows how the vertical displacement of a passenger varies with the time. Add to a graph how the acceleration will change. Add to a graph show how acceleration changes over time. Remember one thing, if this is a displacement time graph, the acceleration time graph will be always a mirror image of the displacement. Like they're always opposite. But So which graph is this? You will identify which graph it appear to be, because starting with a maximum value. So if it start with a maximum value, it means it is a cosine. So for displacement, for acceleration, which graph we have to make? We have to make minus cosine. So minus cosine graph will start with a negative value. So it will start with a negative value, then reach 0. But remember one thing, same function you have to make, like the time interval should be same for increasing and decreasing. So this will be the graph for the acceleration. Is it clear, this graph? The amplitude will be different. Why the amplitude will be different? Because the amplitude will not be, like the value of a displacement won't be same. You can make them on the same scale. Like example, if this is representing the mean position, so in general you can make for the main thing is not about the amplitude of the acceleration, the value, and the vertical the displacement is in the question. Displacement was 0.85 meter, but the acceleration was only 0. The maximum acceleration was about 0.9. So like this amplitude was 0.85, the maximum amplitude. This was 0.85. And but the acceleration is only like minus 0.09. So it means they're not will have the same value. So acceleration will be much smaller as compared to that of the displacement. But the main important thing is sketching a graph. Like the period should be same. Then a passenger on the ship stand on a weighing scale when the sea is calm, read 75 kg. Draw free body force diagram for this passenger. Free body force diagram represent all the forces which are acting. So when sea is calm, it means like the downward force is equals to the upward force. Like the normal contact force and the weight will be equal. Another question, on a rough sea ship oscillate vertically with a large amplitude, why the reading on the weighing scale vary? Look, for example, a person is standing on the weighing scale. Normal contact force is acting upward, weight is acting downward. When it is oscillating up and down, like he's going up and down, as a result, the reading on the balance will change because the net force, the reaction force on the person will change. So if he is accelerating upward, the reading will be equals to the weight when there is like when he's on the mean position, like when he's at the mean position of vibration. When the passenger is above the equilibrium position, as a result, what will happen? To understand this, you can take an example of a spring. See, a spring is there and a mass is attached and it is vibrating to and fro. Now, what will happen? As it is vibrating to and fro, this is a mean position. The center position is a mean position, and these are the extreme position. When it is above the mean position, the forces will change. When it is below the mean position, the forces will also change. So weight is acting downward, normal contact force is acting upward. When it is at the mean position, the normal contact force and the weight will be equal, so the balance will show the same reading. But what if he is above the mean position? Like at this point or this point, anywhere above the mean position. So what is the direction of the restoring force? As we know, in a simple harmonic motion, the force is always directed towards the mean position. Like the direction of a resultant force is always toward the mean position. So it means the direction of a resultant force, if it is above the mean position, the direction of the resultant force should be downward. So if the direction of the resultant force is downward, it means W minus R is equals to MA, or W minus MA is equals to R. So the value of the R will decrease, or the normal contact force will decrease, or the reading on the balance will decrease. When he is below the mean position, weight is acting downward, normal contact is acting upward. And when he is below the mean position, so if he is below the mean position, the direction of the resultant force should be upward. Because as we know, whenever object is vibrating, the direction of the resultant force is always to move towards the mean position. So if it is below the mean position, the direction of the resultant force is upward. If it is above the mean position, the direction of the resultant force is downward. When it is at the mean position, the direction of the resultant force is zero, like it does not have any direction, or the resultant force is zero. So when it is below the mean position, the direction of the resultant force will be upward to restore the mean towards the mean position. So in this case, we can say R minus W is equals to MA, or R is equals to W plus MA. So the value of the R will increase when it is below the mean position. The value of the R will decrease when it is above the mean position, and the value of the R will be same when it is same as a weight when it is at the mean position. So three scenarios are there. Example, if the weight of the person is 75 Newton, the R will also be 75 Newton here. In this case, when it is at the mean position. When it is above the mean position, the weight is 75, the weight is not changing. The normal contact forces are, what is the direction of the result? When it is above, the direction of the resultant force should be downward. So if the direction of the resultant force will be downward, so we can say in this case that 75, the weight minus R is equals to F, or 75 minus R is equal, 75 minus F is equals to R. Means 75 minus the resultant force is equals to R. So value of the R, when it is above the mean position, the value of the R will decrease, or the value of the on the balance will decrease. If the weight is 75 and R is a normal contact force, and if it is below the mean position, so the direction of the resultant force will be upward. So it means R minus 75 is equals to F, or R will be F plus 75, resultant force plus 75. So the value of the R will increase. So throughout the motion, the value of the R, or the reading on the balance, will change. When it is at the mean position, it will be same as the weight. But when it is above the mean position, it will be less than the weight. When it is below the mean position, it will be more than the weight. So when the passenger is below, the reading on the balance will increase. And when the passenger is above, the reading on the balance will decrease. And when passenger is at the mean position, the reading on the balance will remain unchanged. Is it clear, this one? Yeah, reading will be same as R. The reading is actually R. The reading on the balance is actually the normal contact force. So if the normal contact force, then it will change. Now the passenger is standing maximum acceleration. So maximum acceleration when it is at the maximum acceleration is 0.7. Maximum reading on the weighing scale. So maximum reading on the weighing scale when the value of the R is maximum. And which case R is the value of R is maximum when he is below the equilibrium position. Means when he is below the mean position or equilibrium position, weight is acting downward, R is acting upward, and the resultant force should act upward towards the mean position because the mean position is there. So we can say R minus W is equals to F, or R is equals to W plus F. W is mg and F is equals to ma. So R is equals to mg plus ma. So mass was 75, what was given, into 9.81 plus the mass is 75 and the maximum acceleration is 0.7, so 0.7. So the reading, the maximum reading on the balance will be about, this will give us the force, which is 788 Newton. But because it is giving the reading in kilograms, so we have to convert this into kg. So we divide it by 9.8 again. The whole answer divided by 9.8. That will be 80.4 kg. So the reading on the balance will change. So if an object is below the extreme position, below the mean position, the reading on the balance will increase. If it is above the mean position, the reading on the balance will decrease. And when it is at the mean position, the reading on the balance will be same. A similar question, question 11. A child of mass 35 kg stand on a trampoline at equilibrium position with trampoline is displaced 22 centimeter vertically. Show that the constant force on a trampoline is about 1600 Newton per meter. Mass is there. So weight is acting downward. Force constant Newton per kg. So force constant is actually K. K is force divided by extension. How much force is there? Force is equals to weight of the athlete, which is 35 into 9.81. That will be the force. And the extension is how much? 22 centimeter. You have to convert into meter because from the mean position, the trampoline displays 22 centimeter or 0.22 meter. So K is equals to F divided by X. So 35 into 9.81 and the displacement 0.22. When we divide, it will be 1560 Newton per meter. Then the child bounce up and down, always in contact with the trampoline. Calculate the frequency. So if we need the frequency, F frequency is reciprocal of the time period. And T is equals to, like omega, we can use omega is equals to 2 pi divided by T. Or, but we don't know the time period. Or whenever a force constant K is there and M is there, as in this system, K and M are given, K we calculated and M is also given. So we can work out the value for omega, that the omega in this case, or omega square is K over M. So omega square is K over M. So we can work out the omega, which is under root K divided by M. K is 1560 divided by M, 35 kg, that will be root. So we got 6.68 meter per, sorry, radian per second. And we work out omega, and there's also a relation between omega and 2, like omega is equals to 2 pi F. So if we need the frequency, omega divided by 2 pi will be F. So this value divided by 6.65 divided by 2 pi will give us a frequency which is hertz or second inverse, which is 1.06. So the formula of the circular motion are applicable here. Then the height of each bounce above the equilibrium position is 21. Calculate the maximum speed of a child and identify the position at which she has this speed. The maximum speed is given by omega A. So omega, we already worked out in the previous part, which was 6.68, and amplitude 21 centimeter, 0.21 meter, which will be 1.40 meter per second. That's V. And which position it will have? So it will have at a mean position, because at the mean position, the velocity is maximum. So at the mean position, the velocity will be maximum. And the child bends her knees and push against the surface of a trampoline. Her amplitude of oscillation gradually increase. State the effect and explain why there's a... So when the child bends the knees, that causes the maximum acceleration. Always, why the mean position? Like you can take an example of a simple pendulum. So when the pendulum is at extreme position, the speed is 0. But when it moves towards the mean position, the speed is maximum. So whenever even object is oscillating, vibrating in a vertical plane, the mean position, the center position, it will always have the maximum. Like, because the acceleration is always directed towards the mean position. So maximum change happen when it reaches the mean position. At mean position, there is no change in velocity. So when the child bent the knees, causing the trampoline to vibrate, like name of the effect is a resonance. And what actually happened in the resonance? So when the child is using the knees, she is forcing the oscillation, and that is applying a frequency equal to natural frequency of the trampoline or the system. So maximum amount of energy will be transferred. As a result, greater amplitude of vibration happen for the trampoline. So you just have to explain the concept of resonance here. And as her amplitude of oscillation increases, she start to lose the contact with the surface of a trampoline. Why the motion can no longer be described as a simple harmonic? Because in a simple harmonic motion, the two condition, acceleration is directed towards the mean position, and it is always directed towards the mean position. It is increases with the displacement. This is a condition for simple harmonic motion. But when the child loses her contact, like if she is not in contact with the trampoline, her acceleration is no longer directly proportional to displacement. Her acceleration is now equals to gravity. So first thing, how you score the marks? First thing, you'll mention the condition for simple harmonic motion, that acceleration should be directly proportional to displacement from the mean position, and it is always directed towards the center. But when the child loses her contact, her acceleration is not proportional to displacement. Her acceleration becomes constant because of gravity. Because the force of a gravity or weight is acting on, weight is the only force. When she loses the contact, weight is the only force acting on her, if we ignore any effect of the air resistance. So our acceleration become constant. So acceleration cannot be constant for a simple harmonic motion. It should change as the object changes the position. Its acceleration will be maximum when it is at the extreme position. So at extreme position, the acceleration will be maximum. At the mean position, acceleration will be 0, and it vary from mean to extreme. But when she loses her contact, she is no more in contact. So as a result, her acceleration becomes due to gravity. And In a simple harmonic motion, the force is always directed toward the mean position. But in this case, what will happen? Force always remain downward, irrespective of object move upward or downward. Like if object is moving upward or object is moving downward, the force will remain to downward. So that also you can refer. So these are the questions related to the simple harmonic motion. Any question or a doubt related to the session today?